Hi, on this lecture video, we'll be going back to recap some of the things that we can do with dimensional analysis, and in this case, conversions among the units. So we have seen already that dimensional analysis is a very powerful method for solving word problems, right? And we can also use that to do some basic unit conversion as well. For an example, conversion among the stock conversion factor. So the stock conversion factor refers to, again, units within the same physical quantity, such as units within length, mass, or volume, and so on. And these are some of the conversion factors among those units. So when it comes down to length, we have 1 inch equal to 2.54 centimeter, 1 meter equal to 39.4 inch, and so on. So again, let me just repeat this, that on exams and quizzes, this conversion factor right here will be given to you. However, the conversion factor among the metric system, for example, 1000 milliliter equal to 1 liter, those will not be given. But conversion factor between metric system to the English system will be given to us. Okay. So let's now try an example of unit conversion using dimensional analysis. So in this case right here, we have a pencil that is 6.5 inches long. So what is this length right here in centimeter? So in this case right here, our starting unit will then be 6.50 inch. And the wanted unit will then be in centimeter. So the conversion factor that we need to have will be one that requires that convert inch into centimeter. And when we look at this list right here, we see here 1 inch equal to 2.54 centimeter. So that is the conversion factor that is needed. And finally, setting this up to solve this, starting from 6.50 inch. And now we're going to be putting 1 inch on the bottom equal to 2.54 centimeter. Now the one here is actually assumed to be exact. So in this case right here, after we plug this into our calculator, we will be able to obtain 16.5 centimeter. And now we need to round this to 3 significant figure, and it has 3 significant figure on it. So there you go. Basic unit conversions using dimensional analysis. We can also use dimensional analysis to convert among the different SI prefixes as well. So this is what makes dimensional analysis so powerful. Okay, now before we can use dimensional analysis to solve and convert between the SI prefixes, it's important that you know first how to use the SI prefixes and basically be able to convert that to the base unit or the base prefix, which is basically 10 to the 0 without any prefix on it. So you have to remember the relationship between the different SI prefix, and is that bigger or smaller to 10 to the 0, the base. For an example, 1 kilometer equal to 1 or 10 to the 3rd meter, right? So make sure you know how to come up with this conversion factor right here. And this is quite easy because we simply see 1 over here is 1. And now kilo refers to 10 to the 3rd followed by meter. So we simply take out the prefix kilo and we change that into the exponent that it corresponds to. So that's how it would be. And now in this meter right here, this is the base. This is something we call the base right here because it does not have any SI prefix on it. So know the relationship between any SI prefix to the one without the prefix on it. So that's something we call the base prefix. Okay. And another example, 1 micro. Then when we convert this and find its relationship to the base of 1, then equal to the following. 1 is 1, so we don't have to transfer the 1 over. And our micro is then 10 to the negative 6, followed by the unit gram. So 1 microgram equal to 10 to the 6 gram. And that is the other example. And maybe another one, 1 femtosecond. Femto is 10 to the negative 15, right? So 10 to the negative 15, followed by the unit second. So 1 femtosecond equal 10 to the 15 second. Okay. Now there is another conversion factor that you need to also be able to recognize for this as well, and they're the following. So you can see here in this case right here, 1 kilometer equal 10 to the third meter, right? But sometimes make sure you also familiar yourself with the other conversion factor as following. 1 meter equal to 10 to the negative third kilometer. So make sure you are familiar yourself with the other conversion factor as well. And these two conversion factors right here basically are the same thing. So on the first one, the kilometer is set equal to 1 versus the one on the bottom, the meter is then set equal to 1. But mathematically, they are the same thing. And the reason why is as follows. If we were to divide both sides by 10 to the third, then 10 to the third over 10 to the third equal to 1, and we have meter. Now 1 over 10 to the third will then equal 10 to the negative 3 kilometer. So therefore, mathematically, they're the same thing with each other. Okay. And similarly with this one right here, by taking both sides and divide by 10 to the negative 6. 10 to the negative 6 over 10 to the negative 6 equal to 1 gram. And now 10 to the divided by 10 to the negative 6 will then equal to the positive exponent. And now microgram. Unit microgram. So 1 gram equal 10 to the 6 microgram. Okay, and the other one over here is again, we can divide both sides by 10 to the negative 15, which then give us 10 to the 15 femtosecond equal to 1 second. So be able to recognize both versions of this same conversion factor right here, one or the other. Okay, and when you see them being used, please do not get confused by them. So now let's do some of the basic problem right here involving converting the among the different SI prefix to using dimensional analysis. So here in this case right here, we ask to convert kilometer into centimeter. So the approach is as follows. Here we have kilometer, right? So first we convert this into the base. And once we have this base already, we can now convert this into centimeter. So it requires 2 steps right there. So this is why it's important that you know the relationship of what this prefix means to the base. Okay, so in this case, we can do the following. 0.5 kilometer, that is the starting unit. And now first, we want to convert this into meter. And then once we have meter ready, we can then convert this into centimeter. And now when we set this up, 0.5 kilometer, that is the starting unit. And now we see the following. Again, going back here, 1 kilometer. And we want to put 1 kilometer on the denominator. And 1 kilometer equal to 10 to the third meter. So therefore, we put in 10 to the third meter on top. And now to convert meter into centimeter, we then see the following. We're going to put 1 centimeter first because that's the new unit that we want. And 1 centimeter is simply 10 to the negative 2 meter. Right? We simply convert this centi into 10 to the negative second power. And there you go. So in this case right here, we will then see kilometer cancel out, meter cancel out, and we'll end up with centimeter. So in this case, it's equal to 5 times 10 to the 4th centimeter. And we'll be rounding this to one significant figure. This value have infinite amount of sig fig. This have infinite amount of sig fig as well. And the reason why that this are conversion factor among the prefixes in the SI system, which come from definition. So this is why that they have infinite amount of sig fig. So the value that we are using to round the final answer is the 0.5 kilometer. Okay, so why don't you try B before we go over the answer together? And now let's go over the answer. So in this case right here, we're starting from microgram. We can convert microgram into gram and then gram into kilogram. So that's what we can do with dimensional analysis rather than converting microgram into gram directly by moving the decimal point, we can break this into smaller parts and convert that first into the base of one, to the base of 1 first, and then to the other prefix. So in this case right here, to now solve this, starting with 455.343 microgram. And now I want to put 1 microgram here first. And now so it will get cancelled out. And now I know 1 microgram will then equal 10 to the negative 6 gram. So that's how I would be putting this in to cancel out and convert microgram into gram. And lastly, the other unit that I want to convert into a kilogram, right? And now I'm going to be putting kilogram on top. And 1 kilogram will then equal to 10 to the 3rd gram. So there you go. That's how this would also be cancelled out. Okay, so gram cancel out with gram, microgram cancel out with microgram. So in this case right here, we would then have 4.55343 times 10 to the negative 7 kilogram. And we have to round this to 6 significant figure, okay? Because it is this value right here that dictate the amount of sig fig. Both of this have infinite amount of significant figures. And now the third thing that we can do with dimensional analysis that is really powerful, and this may be a new topic that we have not seen before, so please make sure you pay attention to this. So dimensional analysis and how we can use it to convert among units that are raised to a power. Now we have seen already that when a particular unit is raised to a particular power, it now becomes a unit of a different physical quantity, right? For an example, length raised to the first power would still correspond to the unit of length. However, when length, the unit of length, is raised to the second power, this is now no longer the unit of length, but now this is the unit of area. And similarly, when length, a unit of length, is raised to a third power, this is now become a unit of volume. Okay, and for an example, one relationships that is very important that show the relationship between length to the third power and the typical unit of volume that we have seen already is 1 cubic centimeter equal to 1 milliliter. This is a very important conversion factor that we need to remember, okay, because it converts a cubic length into a typical unit of volume. So whenever we have to convert between cubic length to a typical unit of volume, then we have to go through this conversion factor right here. So this is why that it's important that we remember this. Now let's go back to conversion factor. So when the conversion factor between units that raise to a power are not the same thing as the base conversion factor when the conversion factor are raised to the first power. For an example, 1 inch equal to 2.54 centimeter. And this is the base conversion factor right here when both of the units are raised to the first power, right? But would we think that if we were to have cubic inch and cubic inch and cubic centimeter, with this value right here would still be the same thing. So because 1 cubic inch equal to 2.54 centimeter, well, is it then true for us to say that 1 cubic inch also equal to 2.54 cubic centimeter? And the answer is no. Okay, it's not. So how do we find the relationship between two units when they are raised to a power? Here is how we would do it. So in this case right here, so when converting quantity with unit raised to a power, the value must also be raised to that power as well. So here how we would derive the relationship when certain units are raised to a power. So in this case, again, let's go back to 1 inch and equal to 2.54 centimeter. And now to find the relationship between cubic inch to cubic centimeter, we have to do the following. First, raise both of them to that same power right there. In this case, the third power. And now, distribute that, the power to both the unit and the value. So in this case right here, 1 to the third, and then inch to the third. So we distribute this 3 to both the unit and the value. And same thing on the other side. We now need to distribute this 3, this third power. So this equal to 2.54 raised to the third power. And now centimeter would now be raised to the third power. And after that, when we solve this, 1 to the third power will still equal to 1. So 1, and now inch cube. 2.54 raised to the third power now equal to 16.387. And now the unit is cubic centimeter. So this would be the conversion factor between cubic inch to cubic centimeter. And clearly, this is not the same thing as the base unit, where 1 inch equal to 2.54 centimeter. 1 cubic inch actually equal to 16.387 cubic centimeter. Okay, so that's how we would find the relationship when certain units are raised to a power. Let's now try another example. So 1 feet equal to 12 inches, right? So that is the base unit right there. So here we can also see that 1 cubic feet will not equal to 12 cubic inch, right? But it has to be something else. So here in this case right here, how do we figure it out? Then the answer, we have to again go back to the base conversion factor first. And now raise both sides to that same exponent that we want. It can be the second exponent, third exponent, or any types of exponent that we want. In this case, the third exponent. And now we have to factor this out. Distribute this out. So this one equal to 1 cubic feet, and this equal to 12 to the third power, and now inch square. So 1 cubic inch, 1 cubic feet is actually equal to 10 to the third power cubic inch. And when we multiply this out, this would then equal to 1 cubic feet equal to 1728 inch. Okay, and this value right here would then be known to have infinite amount of significant figure. And the reason why it came from this definition right here. Okay, so when we obtain this value is also an exact value as well, since it derives from the definition. And now let's try some dimensional analysis problem involving units that are raised to a power. So here is a problem. A swimming pool has a dimension of 50 feet long, 50 feet wide, and 12 feet deep. What is the volume of this pool in gallon? Solve this by using dimensional analysis. So first, we are given the dimension of a pool. And if we are given the dimension of it, length, height, and width, we can multiply these three together and be able to obtain its volume, right? So in this case right here, the volume of this equal to 50 feet multiplied by 15 feet multiplied by 12 feet, which would then equal to 9,000 feet in cubic feet, to be exact in this case. Okay, so we are given this volume right here in cubic feet, and we ask what is this volume right here in gallon. So in this case right here, the starting unit is basically cubic feet, 9,000 cubic feet, and cubic feet right here is a unit of length. So this is a unit of volume right here, except it is the unit where length is raised to a third power. Okay, and the wanted unit here would then be gallon, and gallon is then the typical unit of volume. So we need to be able to convert cubic length into volume. So therefore, the conversion factor that we require will be something that have to relate length to the third power or cubic length to volume. That is the required conversion factor that we need. And now we remember that when it comes down to the relationship between cubic length to a typical unit volume, then we know that cubic length, 1 cubic centimeter, equal to 1 milliliter. So this is something that we have to be able to use in order to solve this problem. So therefore, the first step is for us to convert from cubic feet into cubic inch, and from cubic inch into cubic centimeter. And when we have that already, we can now convert into milliliter, and from milliliter into liter, and then into gallon. So the solution map for this problem will be as follows. Starting with cubic feet, we have to convert this into cubic inch, because we know how to convert from feet into inch. And then from inch, we can convert this into centimeter, and in fact, cubic centimeter. And once we have cubic centimeter already, we can then convert this into milliliter, and milliliter into liter, and then liter into gallon. So there are quite a few steps that we have to do here in this case. And now let's get started. So in this case right here, 9,000 cubic feet. Now, so I'm going to show you this trick right here, how to help make it much more simple when we set this up right here. And this is by doing the following. 1 cubic feet. 1 feet, start first with the base unit, equal to 12 inches. So first put down the base unit, and now raise both of them into the third power. And that's how we will be able to cancel out this cubic feet right here. But you just have to remember that now when we multiply this out, we have to take the 12 and raise that to this third power right here. Okay, so in another way how we can also do this is as follows. Go back to the same base unit. 1 feet equal to 12 inch. Now do the following. Raise this to the third, raise it to the third, raise this to the third, and raise that to the third. And now we can see that will get cancelled out. Okay, and going back again, so similarly, to convert cubic inch into cubic centimeter, we can do the following. 1 inch equal to 2.54 centimeter. And now we need to raise this to the third power, right? So 1 to the third power, which still equal to 1. And now 1 to inch to the third power within cubic inch. And now raise this to the third power, raise this to the third power. So now cubic inch would get cancelled out. And next we need to convert cubic centimeter into milliliter. And we know that 1 cubic centimeter equal to 1 milliliter. So now the cubic centimeter would get cancelled out. And then milliliter into liter. 1,000 milliliter equal to 1 liter. And now the milliliter would get cancelled out. And now for AV, and now lastly, liter into gallon. 3.785 liter equal to 1 gallon. And now liter would get cancelled out. So in the end, when we multiply all of this out, then the answer would then equal to 67332 gallon. And now let's talk about, let's actually be very careful. I'm going to show you how to plug this into your calculator. So on your calculator, you have to first open up a parenthesis and put 9,000, and then multiply by 12 to the third power, multiply by 2.54, and this value is raised to the third power. And now we don't need to multiply by the 1, right? And now on the denominator, we make sure you open up a parenthesis and now have 1,000, because again we don't need to divide anything by 1, and then multiply by 3.785. So that's how you would plug this into your calculator to obtain that value. And now let's talk about the rounding of this value right here. How many significance should we round this answer to? So here in this case right here, going back all the way to this first problem, this value 9,000, how many significant figures it has? The answer is actually 2. Even though we write this 99,000, we're supposed to write this at 9.0 times 10 to the third, because the reason why would because it comes from this volume calculation right here, 50. So in this case right here, actually this will have one significant because this 50 feet right here, based on the way it is written, has only one significant figure on it, right? So perhaps maybe we should have put a decimal here to make it better, but in the way it is being written right now, if we have no decimal point right here, this volume right here will then have only one significant figure on it. Okay, so let's make this correction. That actually wasn't what I intended, but because I forgot to put a decimal point right there, so now we can only count one significant figure on it. Okay, so all of this value, so this value here, it comes from definition, so infinite amount of significant figure. This value, 3 significant figure. This value, infinite, and this value, 4 significant figure. So our answer would then be rounded to 1 significant figure. So in this case right here, it would then be 70,000 gallon. Okay, we can keep it in decimal form, or we can also convert this to 7 times 10 to the 4th gallon. And that will be the final answer.